Equations. Equations are mathematical statements that imply that things are equal on both sides of the equal sign. In fact, equations work exactly like a balance scale. We've got our scale loaded here. We've got 6 batteries on each side of the scale, and you'll notice that the scale is perfectly balanced. If I want the scale to stay balanced, much as I want an equation to stay balanced, whatever I take out of the left side of the scale, I'm also going to have to take out of the right side of the scale. For example, if I wanted to take 2 batteries out of this scale, it throws the scale off balance, unless I take an equal number of batteries out of this side of the scale. That way, if I remove 2 batteries from each side of the scale, I notice that it stays balanced. I'm subtracting 2 batteries from both sides of the scale. Perhaps I would want to divide the scale. I would want to divide the contents in half. So I have 4 batteries in this scale, 4 batteries in this scale, and I want to divide the weight in each balance by half. I would take away 2 batteries from each side again, and you'll notice that the scale stays balanced. So I can do subtraction, I can do division. Perhaps I'd want to add weight to both sides of the scale. I'd want to put in another battery on each side. As long as I put one on each side of the scale, my batteries will keep the scale balanced. I added one to the left, I have to add one to the right as well. Perhaps I'd want to double the number of batteries in each side of the scale. I have 3 on each side, so if I wanted to double the number of batteries on each side of the scale, I would have to add 3 more to each side. I'm going to add 3 batteries to each side, and we'll see that the scale stays balanced because I've put an equal number of batteries in on both sides of the scale. When you're working in an equation, it's much like working with a scale. Whatever you do to one side of the equation, you want to make sure that you do to the other side of the equation. We're going to use the scale to help us model the equation x plus 2 equals 6. I've written the equation on the board here, x plus 2 equals 6. We've modeled it on the scale so that we have x, the unknown, represented by the box, plus 2 batteries equaling 6 batteries. We can see that the weight of the unknown and 2 batteries is equal to the weight of the 6 batteries. If I want to find out how much the unknown weighs, I'm looking really to find out what is in this box, how much weight is in this box. I don't want to have to deal with the 2 batteries that are coupled with it on the scale. I want to take those 2 batteries away. I know that if I take 2 batteries away from the right, I need to take them away from the left. We're going to operate just that way on this equation. If we want to model this equation on the board, we know that the equal sign functions as the fulcrum of the scale. I'm going to take away 2 batteries from one side, and I need to take away 2 from the other. So I'm taking away 2 from both sides of the equation. I'm going to take 2 batteries away from the left and the right. And I see that my equation is still balanced because I've been careful to do the same thing to both sides of the scale. I was careful to do the same thing to both sides of the equation as well. Now, when I look at this on the board, I can see that I only have x left on the left-hand side of the equation because I took away 2. I only have the unknown left on the scale because I took away the 2 batteries. And I know that 6 minus 2 is 4. On this side of the scale, I had 6 batteries, and I took away 2, leaving me with 4 batteries. So when I check, I have 4 batteries on the left. My unknown has the same weight as 4 batteries. Let's check our results and see if it's true. Sure enough, we've got 4 batteries in the box. We found our unknown was equal to 4.